You've already been introduced to traditional or classic topographic maps. Those topographic maps allow you to plot in 3 dimensions on a 2D plane. So on a flat piece of paper, you can visualize the highs and lows of a mass of land. We're pretty used to operating in 3 dimensions because that's how our world works. There's also a 4th dimension that is included on geologic maps. And that might sound kind of Twilight Zone or space agey, but you operate in that 4th dimension all the time. There used to be, and there might still be, an attraction at Universal Studios that was called Shrek in 4D. Please don't use that reference as what the 4th dimension is. I think in that attraction, the 4th dimension is like smells or something. But really, on a geologic map, the 4th dimension that we are plotting is time. So on a geologic map, not only can you see the dimensions of latitude, longitude, elevation for the topographic contour lines, but you can also see the ages of sediments based off of a lithologic key. So a geologic map, this one here is a paper version of the PDF I'll be giving you guys for your lab. I know you can't quite see all of the zoomed in sections from the video, so I'm going to be using an example just to show you. So on a geologic map, you get a wide variety of colors, sometimes a variety of textures, but you also get these key letters that help you to identify and recognize a color swatch from one spot to the next. So if you are operating on a black and white piece of paper, grayscale screen, or perhaps you are not able to see the wide array of colors that are labeled here, you can also refer to the patterns of the infill, or way more specifically and useful are the letters that are included. So it's a lot like a color by number where the entire swatch of one color has a given lettered or numbered code. So here we see PP, PMN, MMC, and those ones just show what the substrate is on this given geologic map. So for a single color, we'll look at this MMC here. We can find out quite a bit of information. We know exactly where it is. If it's on a topographic combo map, you can also see the elevation of that point. And now coming in with the 4th dimension, we can see where that MMC is on our lithologic key, and we can see its geologic time period. We see, as reference from our geologic timescale video, we have the Pennsylvanian and Mississippian listed here. So our MMC sediments appear to come from the Mississippian geologic time period. As you may recall, the Mississippian is also bundled into the Carboniferous. You can know that these are probably carbon-rich sediments, which they are. Limestone is a calcium carbonate rock. So we can tell the age of these sediments. And then it also tells you, I keep saying the word sediments, but we might also have igneous materials here. It tells you what kind of rock it is. So if you recall from our different rock types, limestone, this one is a sedimentary rock that forms in marine environments. So now you can tell from a single map not only where something is, but you know how old it is, what kind of rock it is. And now that you know that this is a limestone, you know a little bit about the geologic history of this point. So you know if you find a bunch of sandstones or limestones within a region and you can tell how old it is, you know that long ago, at that exact point, you might have found beaches or a shoreline. So with a geologic map, you can find out a lot more information of an area. Now, why would you want to know that information? You might not really care that this Santa Clarita Valley has sandstones in it that represent that this was an aquatic environment millions of years ago. You might not care too much about that. But let's say you're buying a home. You might want to know if the home you're buying is built on some quick to erode and collapse karst topography, like you might find in Florida. You would want to know if the land you're building on top of has a joint or fault running through it. In case of an earthquake, you might have some breaking of your foundation. You may be curious if you're digging in your backyard and you find some bones. You might be freaked out and say, is this murder, or are these camel bones from when camels lived here during the end of the Pleistocene? Oh, I know the age of the sediments, that's what it must be. So you can look into what you might find underground in terms of structurally. Geologically, you can also predict where to find oil preserves, where to find potential gold veins, where to find certain fossils, or even things of archaeological relevance. If you want to look for early human civilization sites, you'd want to make sure you're digging in the correct age and correct type of substrate. So with a geologic map, you have a lot of different uses. The cross sections here will not only tell you what types of materials or lithology are at the surface, but what you would find at varying depths if you were to dig. So the cross sections are pieced together through a series of investigatory efforts where people would go and mine for oil wells, dig out material for oil wells, or perhaps there was digging for gold, or digging to put in utility pipelines or wires. And so through all of these different data points, they're aggregated together to say what a certain swatch of the earth or swatch of land is composed of. All right, my phone is buzzing. There we go. So when you're looking on the geologic map that we'll have on our lab, you'll be able to still see all of the man-made features, as well as the age and composition of the materials underneath them. You have a key alongside that gives the different geologic periods, and just like we had the example that was here in my hand where it gives a description of what kind of rocks you'll find in the substrate, you have that here as well. You'll be able to determine if things are sedimentary, metamorphic, or igneous rocks. It'll tell you in some cases where the sediments came from, and you can also see patterns of erosion based off of the topography, where older rocks are exposed in the surfaces of mountains, whilst younger sediments infill the valleys. Another thing you can look at on geologic maps would be structural features that can tell you about different tectonic or seismic forces in the past. That'll make more sense when we get to our structural geology video, but you can look for fault lines or evidence of compression in the cross-section of a geologic map.